Good morning, everyone. Today we'll be reporting about week 6, which is commissioning, decommissioning, and preservation of marine boilers. Before we dive into details, let's explain first why is this so important in marine ships. Marine boilers are essential because they generate steam, which is used for a variety of purposes. Depending on the type of vessel, steam may be used for propulsion in steam-driven ships, for heating fuel oils and cargo tanks, for driving certain auxiliary machinery, or for accommodation heating and other services. Because the boiler is such a vital piece of equipment, it must be always be handled with great care. A poorly handled boiler is not only inefficient but also dangerous. Boiler explosions in the past have caused major accidents, loss of life, and damage to the environment. That is why the international regulations, such as under SOLAS, the Safety of Life at Sea Convention, provide strict guidance on how boilers should be operated, maintained, and preserved. Today, we'll be tackling three major areas. First, commissioning, which is the safe startup and preparation of a newly installed or repaired boiler. Decommissioning, which is the proper shutdown of a boiler, temporary or permanent. Preservation. This involves protecting the boiler from corrosion and deterioration during idle periods.
Topic 1. Commissioning of a marine boiler. Commissioning is one of the most critical processes in the life of marine boiler. It's not just a simple startup. It's a controlled procedure to prepare the boiler for safe, efficient, and long-term operation. We begin with pre-commissioning checks. Imagine a brand new boiler fresh from the shipyard. It looks shiny on the outside, but inside it may be coated with grease from manufacturing, rust from transport, and mill scale from welding. If these impurities remain, they act as insulators, creating hot spots that can crack tubes, or as corrosive agents that eat away at the steel. That's why chemical cleaning is mandatory. The process usually starts with an alkali boil out, where alkaline chemicals dissolve oil and grease. This is followed by acid cleaning, which removes rust, scale, and oxides. Once the surface are clean, fittings and mountings must be checked. Safety valves, gauge glasses, blowdown valves, feed check valves, and drains are usually inspected. Gauge glasses must show the true water level without sticking, and safety valves must be set to left exactly at design pressure. The next major stage is the hydrostatic test. This is like a stress test for the boiler. The boiler is filled completely with fresh water, vented to remove trapped air, and then pressurized to 1.5 times its normal design pressure. For example, a 10 bar boiler would be tested at 15 bar. This test confirms that the boiler can withstand more than its maximum intended stress. Surveyors from classification societies, ABS, DNV, or Lloyd's Register must be present. They certify that the test is successful, or else the boiler cannot be put into service. We move to initial filling and firing. The boiler is filled with treated feed water up to normal operating level. Feed water treatment here is not optional. Untreated water will immediately cause scaling, corrosion, and foaming. Vents are opened to release air and avoid vacuum formation. Then firing begins. This is never done at full blast. Instead, the burner is set at a very low firing rate, allowing the boiler to heat slowly. The expansion of steel is carefully monitored. If one part expands faster than another, cracks can form. As the boiler warms, operational checks takes place. Safety valves are lifted to ensure they pop at the correct set pressure. Alarms and trips are tested by simulating low water levels, high pressure or flame failure. Interlocks must cut off fuel supply immediately. If unsafe conditions occur, burner flame patterns are observed for stability. Poor atomization of fuel leads to black smoke, carbon deposits, and wasted energy. Combustion efficiency is checked by measuring oxygen levels in exhaust gases. Finally, there's the trial operation. The boiler is operated under different loads, from low to high steam demand. To see how it responds, feed water pumps are tested. Fuel oil supply systems are monitored, and water chemistry is controlled using dosing systems. Every reading, pressure, temperature, feed rate, and exhaust gas composition is logged in the boiler logbook. These records prove that the boiler has been properly commissioned and can also help troubleshoot future issues. Topic 2. Decommissioning of a marine boiler. It's a detailed process of controlled shutdown, cooling, draining, cleaning, and securing. The purpose is always the same: protect the boiler, protect the crew, and prepare for the next step, whether that's maintenance, layup, or disposal. The first stage is a controlled shutdown. Load is reduced gradually, never abruptly. Imagine a car driving at full speed and then slamming the brakes. Everything inside gets stressed. The same goes for boilers. Reducing steam demand slowly avoids sudden thermal shocks. Burners are gradually throttled back, and once the steam demand is minimal, the fuel supply is shut off. But that's not the end. The furnace must be purged to remove any unburned fuel or gases. If not purged, residual vapors can ignite during later operations, causing explosions. After the boiler cools, draining and cleaning take place. The boiler water is drained completely. Manholes and handholds are opened, and engineers climb inside for inspection. Tubes are cleaned of soot and scale. Drums are scrubbed, and refractory linings are checked for cracks. This stage reveals hidden problems, tubes and leaks, drum corrosion, or deposits that affect efficiency. Before anyone enters the boiler, it must be isolated from all connections. Steam lines, feed water lines, and fuel lines are shut and locked. The lockout-tagout system is enforced, meaning no valve can be opened accidentally. The furnace and drums are ventilated with blowers until oxygen levels are safe. Without ventilation, deadly gases like carbon monoxide could linger, and an unsuspecting engineer entering the drum could be overcome instantly. Decommissioning may be temporary or permanent. In temporary decommissioning, the boiler is expected to be used again, so the goal is to preserve it in good condition. For permanent decommissioning, especially when ships are scrapped or repurposed, the boiler may be disconnected, stripped or fittings or dismantled entirely. Topic 3. Preservation of marine boilers. Preservation is the process of protecting a boiler when it's not in use for long periods. A decommissioned boiler that isn't preserved will quickly deteriorate. Preservation prevents this decay, ensuring the boiler remains ready for safe reactivation. There are three main preservation methods: wet layup, dry layup, and nitrogen blanketing. Let's start with wet layup. It is used for short-term idle periods, such as ship is docked for a few weeks. The boiler is filled completely with treated and aerated water. Oxygen scavengers like sodium, sulfite, and hydrogen are added to neutralize any dissolved oxygen, which is the primary cause of corrosion. A small pressure around 0.1 to 0.2 bar is maintained to prevent air from seeping in. Water circulation is carried out periodically to maintain chemical balance. If done properly, wet layup can keep a boiler corrosion-free for several weeks or even a couple of months, but it has risk. If the water is neglected or pressure is lost, air can enter and accelerate corrosion. Also, in cold climates, water can freeze, cracking the boiler. Next is dry layup. This is used when the boiler will be idle for months or years. After decommissioning, the boiler is completely drained, dried, and sealed. Internal surfaces are lightly coated with oil or sprayed with desiccants. Containers of silica gel or quicklime are placed inside the steam drum to absorb any remaining moisture. Manholes and openings are sealed airtight. With no water present, corrosion cannot occur. Dry layup is simple, reliable, and widely used, especially for long-term preservation. Then there's nitrogen blanketing. This is the most advanced method. The boiler is filled with nitrogen, an inert gas that displaces oxygen. Without oxygen, corrosion cannot happen. This method is extremely effective for long-term storage, but it comes with challenges. Nitrogen leaks must be monitored, and the pressure must be checked regularly. There's also a danger for the crew. Nitrogen is colorless and odorless, and if it leaks into enclosed spaces, it can displace oxygen, creating a silent asphyxiation hazard. Strict safety procedures are essential when using this method. Regardless of method, regular monitoring is key. Desiccants must be replaced when saturated. Chemical levels in wet layup water must be tested regularly. Pressure must be checked and nitrogen blanketing. And internal inspections should be carried out to catch any early signs of corrosion in the boiler.
Throughout all these processes, commissioning, decommissioning, preservation, safety, and environmental protection are top priorities. Always follow SOLAS regulations and ship safety management system. Ensure that boiler water treatment chemicals are handled responsibly, avoiding discharge into the sea. Keep proper logs and records for inspection, which also helps tracing issues later on. To conclude, we have covered three aspects of boiler operation. First, commissioning, which is ensuring a boiler is clean, tested, and safely started. Decommissioning, shutting down the boiler carefully and preparing it for maintenance. Preservation, protecting the boiler from corrosion and deterioration when it is not in use. Each of these steps requires attention to detail, strict safety protocols, and compliance with regulations. By doing them correctly, we extend the life of the boiler, improve efficiency, and most importantly, protect both the crew and the environment. That's the end of our report on week 6, so about commissioning, decommissioning, and preservation.